Hey, what's happening, LinkedIn? Coming at you here live from the backyard. Got the dogs out here playing. Looks like it's going to rain. So, if you've been watching the Twitter feeds, you might have seen Vitalik Buterin and Elon Musk kind of going back and forth talking about some of the advantages of cryptocurrency and some of the things that we can see that can be done with the Ethereum blockchain. So, since Elon is kind of a astronaut kind of guy and out of this world kind of guy, there's an online challenge from Open Zeppelin called the Ethernaut Challenge. And in this Ethernaut Challenge, it teaches you a great deal about Ethereum. So what I'm going to do today is I'm going to teach you guys how to become Ethernauts. So come with me now, and I'm going to show you how. All right, guys, so what we're going to do now is we're going to go ahead and take a look at the Open Zeppelin Ethernaut Challenge. So what exactly is the Open Ethernaut Challenge? Who is it for? Why are we doing it? How are we going to do it? When are we going to do it? Let's answer all those questions. So Open Zeppelin, if you're not familiar with Open Zeppelin, they're open source. They create Solidity smart contracts and provide them to the community on GitHub in their GitHub repositories. And so there's a massive amount of open source contracts, such as ERC20 contracts that will mint tokens for you that we can use and encapsulate in our smart contracts when we create new Solidity smart contracts in order to ensure that we adhere to best practices. It's always better and easier for us to start with a bunch of pre-built items instead of building everything from scratch, especially when we know that a lot of those items have been tried and true and tested, and that's usually what we see with these open source Solidity contracts. So if you're not familiar with open source and Solidity, and Open Zeppelin, and Solidity, and their Solidity library of contracts, I highly encourage you to go out and take a look at Open Zeppelin and take a look at what they're doing. All right, so we're going to be going in through their Ethernaut Challenge, which is basically an over-the-wire capture the flag type challenge that was put out a couple of years ago. But we can still go through them in order to find vulnerabilities in smart contracts. Now, most of the solutions have already been found. They're published out there on GitHub repositories, so you can go ahead and find them and then use those solutions, or you could go ahead and come up with your own solutions on your own. Really just kind of depends on your skill set and your skill level, whether or not you want to cheat. I guess it's kind of up to you. So anyway, so that's basically what this is going to be about. I'm going to kind of walk you through a lot of these solutions. So in essence, this is going to show you how to go through and get set up today, and then we'll walk through each of the solutions that have been produced since the start of the Ethernaut Challenge. Cool. So again, we're going to be doing this over a series of videos. This is our first video, just showing you how to get it set up, and then I'll walk through each one of these, and I'll do these, every few days. Cool. And so how are we going to kind of go through this? Again, we're going to go through each one of these challenges. I'm going to try to record each one of the steps and explain it to you the best as I can. If you have any questions, or maybe if I even mess anything up, please let me know, and so we can get everything straight. So as John F. Kennedy said, a rising tide lifts all boats. And so hopefully by going through this, this is going to help all of us have a much better understanding of how the security works in smart contracts, especially in Ethereum and Solidity. And that's going to be really important, especially if you have any kind of aspirations to work as an Ethereum developer or work anywhere within the DevOps operations within Ethereum or within a product that's going to be designed with an Ethereum or any kind of blockchain backend. It's going to be important that you understand these concepts. Cool. All right, so let's go ahead and kind of talk a little bit about what we're going to be doing. We're going to be actually using our browser with the MetaMask plugin in order to interact with these smart contracts. So it's going to be really important that you have Chrome or Brave. I think Opera works too, but you need to have that MetaMask browser plugin installed, and then you also need to go to the Ropsten network, which is a test network on Ethereum, and actually fund the wallet that you'll be using in MetaMask. So there's some instructions on the Open Zeppelin page that I'll be navigating to today. If you want to navigate to that page and you follow those instructions, they'll walk you through how to do that. If you have any problems or questions, you can always reach back out to me and I'll be able to help you. All right, so let's go ahead and get started here. I'm going to go ahead and go out to HTTPS Ethernaut Zeppelin.solutions. And this is going to bring me here to the Open Zeppelin challenge. It just tells us again that this is a Web3 Solidity-based war game that's going to, in essence, give us the ability to interact with the Ethereum virtual machine, get a much better understanding of how smart contracts work, and understanding of how those smart contracts could be hacked. And so we're going to kind of play around with those smart contracts. So we're going to go ahead and just click play now. We're going to go ahead and get started, and it's going to just kind of introduce us to this as saying hello Ethernaut. So we're an Ethernaut by being involved in this, and it's going to have us set up MetaMask. Now, of course, I already have MetaMask set up here, so you'll see this in your browser, and it'll show kind of how much Ethereum that you've pulled from the faucet, and it'll also show you kind of what network you're connected with. If you wanted to change the networks, you can change that here, but this is going to be on the Ropsten network. So you need to make sure you're on the Ropsten network, and you also need to make sure you're connected with an account that has some Ethereum in it. If you don't, you'll need to open up one of your test accounts that you've imported and or created using these options down here, and then fund that account. So I'm going to go ahead and use this account here. It's got a little over 10 Ethereum in it for our demo today. So let's go ahead and get started there. And so now that I have, I know that I have my MetaMask installed. One of the other things that we're going to need to have is we're going to be using the inspect element functionality that's in our browser. So when you go to inspect, you'll notice it'll bring up this little lower window here, and I'll need to go over to my console. And so this is where we're going to be interacting. It'll show you here. It says hello Ethernaut, type help for a listing of commands. So here, and it shows you my address, and so level address is right here. And then also you'll notice here, I want to kind of show you something. This is the address 0x8BD. Okay, so just kind of remember that. That's the address of the account that I'm connected with, because we're going to be interacting with that account quite a bit in this console. So I'm going to go ahead and just type in player here. And when I type in player, you'll notice that's exactly what comes back, is that address that I just talked about. So there's the address of my account that I'm currently coming in with. So it recognizes me as the player. Cool. So that's what we see there. And so now we want to see what our balance is. So we know that our balance is a little over 10 Ether. But let's go ahead and see what happens when we interact with the contract to get our balance. So we do a get we do a get balance. And then we're going to go ahead and pass the player parameter in there. And then you'll notice that it comes back with this promise and pinning. If I expand this out, it'll kind of give me the values in here, but I kind of got to dig for it a little bit. So since I'm using the Chrome web browser, I actually have to put this await in here, and then I can go ahead and put in my get balance command. So I do a get balance and then my player, and that should work for me there. And so then it shows me my balance. Perfect. And then another thing you can do that'll always come helpful here is you can always just run help, and it'll kind of show you all the various different methods that are available from here within this console and interacting within this particular web page that you navigated to. Cool. So now what I want to do is I actually want to interact with the particular contract, and I know that the contract is Ethernaut. So I'm going to go ahead and just put that in here and see what happens. And when I put in Ethernaut, it comes back, and this is the game's main smart contract here. You don't need to interact with it directly, but you can kind of see what's going on with it. So I'm going to kind of make this console bigger here so we can look at it a little bit better. And if I expand this out, you'll notice that this is the application binary interface, or this is the ABI. This is the address that kind of published this particular contract. I can see kind of the inputs and the outputs for the various different functions that we have within this ABI array for this smart contract. So this is kind of the things that we can do within the smart contract, stuff like that. Cool. All right, so we're going to go ahead and move this back down here. And so one of the things that it wants us to do within that smart contract is it wants us to find out who the owner is. So we're going to go ahead and just do a request for the owner. We're not going to pass any parameters in. We're not changing who the owner is. We're just simply finding out who the owner is. So let's go ahead and do that. So if we do Ethernaut.owner, and we do the await. So let's go ahead and do the await here. I'll make this a little bigger so everybody can see. I'll clear this out so you guys can see this a little better. So we'll do an await contract. I'm sorry. Await, what is it? Await Ethernaut.owner, not contract.owner, sorry. Ethernaut. We haven't minted our own contract yet, so we can't do the contract there. So await owner, and then we'll go pass that in, and then it comes back. It tells us the owner of that smart contract. Now, I know that it took us a little bit of kind of messing around there, but that is actually probably the same address that we saw when we were looking at that ABI array earlier. So if you want to go back and look at that, you certainly can. All right, so now, it's telling us that we need to get some test ether. Well, we've already done that, so we can kind of skip through that part. And it tells us, if we want to get to the level instance, we can do that, and then we can inspect the contract. And so before we can inspect the contract, what we have to do is we have to get our level instance. So in order to get our level instance, what it's telling us to do is to go down here to the bottom and select Get New Instance. And so when I click on Get New Instance, you'll notice that it pops up my little MetaMask window, and it says it's going to have to go ahead and create a new instance of a particular smart contract. And in order for me to create a new instance of an existing smart contract, I have to basically create that smart contract, or I have to instantiate that new contract. And so I have to pay the gas to do that. So that's what this is doing. It's not real money. It's money on the test network. So we got that through the faucet, and we saw that earlier. So I'm going to go ahead and confirm this. And so now it's going to go out and mine this transaction. So this is going to take a second. It actually gives us a link here to our Ether scanner. So if we want to go out to the Robson Ether scan and mine this transaction, then we can see it's pending. The block is pending, and you'll see it's the same thing. It's kind of telling us the same thing. It's attempting to mine that transaction, and it's just getting additional information from the transaction as it's being mined. And so this is just going to continue to retry until the Robson network actually mines our transaction. And there it says it's confirmed, right? So there, as soon as we got that confirmation, we see the confirmation here. Awesome. So now what we're going to do is now we can actually interact with that instance of that contract. So if we wanted to look at the info on that contract, we could just go ahead and put that in there. Now, of course, we're going to prefix that with the await like we were doing earlier. And so now it's telling us that we will find what we need in info1. So I'm just going to say await. Okay, so contract.info1. And so now I'm going to find what I need in there. Okay, cool. So let's go ahead and follow this along and see what's going on here. Okay, so now, it's telling me, try info2, but instead, when you try info2, do it with the hello as a parameter. So we're going to go ahead and do that. So if we just go back here and then say info2, and then just do hello, and then let's see what happens here. Now it's telling us, okay, so there we passed that. Now it's telling us, okay, the property info num holds the number of the next info method that we need to call. So it's telling us that we need to call another info method, but we don't know the number of that info method. In order to get the number of that info method, we have to look at the property info num in order to get that. So let's go ahead and do that. So we're going to go to the info num property, and we're not passing any parameters into that. So we're just going to go ahead and pull that back. And we can see that that's coming back, but it's coming back in an array. And so I can actually see that the first value in that array is 42. But another way that I can kind of go through this is I might have to pass that to a string if I wanted to do that. But I can see that's 42 here. So I know that that's the next thing that I need to get, the next info method that I need to call. So let's go ahead and try that. So we'll say try call info 42 instead of 2. Let's see what happens there. And now it's okay. So there we go. So now it says the method name is the name of the next method. Okay. So, so we go ahead and just do the method name. The method name is the name of the next method. All right. Okay. The method name is method 72 da 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 da. Okay. So now we're going to go contract method 72 da 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 712. There we go. And so now it's telling us, okay, so there we go. So we pulled that in. So now it's telling us, okay, if you know the password, then go ahead and submit it to authenticate. Okay. So we need to know what the password is. So we need to figure out what the password is. So let's go ahead and figure out what the password is if we can. So let's try to figure out what the password is. The password is Ethernaut 0, but we got to submit Ethernaut 0 to authenticate. Okay, so let's try that. So we need to go to authenticate. Okay, cool. And we need to pass in Ethernaut 0. Cool. Let's try that. See if that works. Ta-da! Let's see. Now we're mining the contract. Let's see what's happening here. I think that's good. Bam, bam. We'll go ahead and confirm that. It's mining our transaction. And there's our transactions confirmed. There we go. We can look at it out here on Robson if we wanted to. Anyway, the transaction is confirmed. So I think that's it. Okay, so we should be good. We see everything's kind of good. This transaction's been included into the block. It's on our Etherscan. We're in good shape here. So I think we should be able to go ahead and submit this. And so now it's telling us it's going to submit our level. So it's basically taking all of that information that we kind of did and submitting it and seeing if we did a good job, if we did what we were supposed to. And so now we're going to see if that works. Dun, 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 dun. And congratulations, you have completed this level. You guys kicked ass. I hope you enjoyed this little exercise, and we will see you in the next one.